In this video, we are going to solve polynomial inequalities using the test point method. Let us look at our problem. So we are going to solve for x. So I'm going to just factor out one of our x's here, and we're left with x squared minus 4x minus 12 is greater than 0. Then we can factor some more. So we have x times x plus 2, x minus 6 is greater than 0. So now I'm going to set each x equal to 0 and solve. So we have x is equal to 0. We have x plus 2 is equal to 0. And we have x minus 6 is equal to 0. Which means we have x is equal to 0, x is equal to negative 2, and x is equal to a 6. So now we're going to draw a number line, and we're going to put each one of these values on the number line. So we have 0, 1, 2, 3, 4, 5, 6, and I'm just going to add one more, 7, and we have negative 1, negative 2, negative 3. I think that's enough. So since we don't have a greater than or equal sign, and we only have a greater than sign, we know that x cannot equal 0, it cannot equal negative 2, and it also cannot equal 6. But we don't know if x can equal anything in between these values. So we want to use the test point method. And we are going to test a number below negative 2, a number in between negative 2 and 0, a number in between 0 and 6, and a number that is after 6. Now you can choose more than one number, but I'm just going to choose the easiest one. So first I'm going to start with a negative 3. I'm going to plug it into our original equation and see if that number is greater than 0. If that number is greater than 0, then all the numbers below 2 is a solution. However, if the number is less than 0, then all of the numbers below 2 is not a solution because it does not agree with our original equation. So I'm going to plug in negative 3. So we get negative 3 cubed minus 4 times negative 3 squared minus 12 times negative 3. And we want to ask ourselves, is it greater than 0? Okay, so what I've written here is equal to a negative 27 minus 4 times 9 plus 36, which means we get negative 27 minus 36 plus 36, which means we get a negative 27. Negative 27 is less than 0. Therefore, it does not agree with our original inequality. So therefore, everything below 2 is not a solution. Now let us plug in a negative 1 because negative 1 is between negative 2 and 0. So if I plug in a negative 1, we get negative 1 cubed minus 4 times negative 1 squared minus 12 times a negative 1. And we want to ask ourselves, is it greater than 0? So we get a negative 1 minus 4 times a positive 1 plus 12, which means we get a negative 5 plus 12, which gives us a 7. 7 is greater than 0. Check. Therefore, all the numbers between negative 2 and 0 is a solution. Now let us test the number 1, because the number 1 is between 0 and 6. So if I plug in 1, we get 1 cubed minus 4 times 1 squared minus 12 times 1. And we want to ask ourselves, is it greater than 0? So we have 1 minus 4 times 1 minus 12, which gives us negative 3 minus 12, which gives us negative 15. Negative 15 is less than 0, therefore all of the numbers between 0 and 6 is not a solution. Now let us check all of the numbers after 6. So we're going to check 7. So if I plug in 7 into our original inequality, we get 7 cubed minus 4 times 7 squared minus 12 times 7. And we want to ask ourselves, is it greater than 0? So 7 times 7 is 49, right? But 49 times 7, we get 7 times 9 is 63, carry 6. 7 times 4 is 28. 29, 30, 31, 32, 33, 34. So we get 343 minus 4 times 49 minus 12 times 7 is 84. So now we get 343 minus 196 minus 84. So then we get 343 minus, and if I take 196 and add it to 84, we get 280, and if we subtract 343 from 280, we get 63. Sure enough, 63 is greater than 0, therefore check all of the numbers after 6 is a solution. So we write our final answer as from -2 to 0, union from 6 to infinity.